on page 438 where it says thermal energy unit. Okay? Thermal energy. Okay? We talked about heat transfer before. Okay, thermal energy wise, now we're talking about BTUs, calories, and these type of things, right? BTU, calories, joules, whatever, okay? So if you go to page 439, the calorie, okay, so let's look at 1 BTU first. 1 BTU is formally defined as the amount of thermal energy needed to raise the temperature of 1 pound mass of water by 1 Fahrenheit. So 1 BTU is the energy required to raise 1 pound mass of water 1 degree Fahrenheit. Okay, so that's what a BTU is. Correspondingly, okay, a calorie is 1 calorie is going to be 1, not pound mass, but 1 gram of water. Obviously, since it's an SI unit, it's not going to be Fahrenheit, it's going to be Celsius. Okay. BTU versus calorie. So that's the blah, 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 blah. Okay, we're good. Okay. And this was the part where you were not able to do number 1 or number 4, I think, on the homework, right? Given this, you should have been able to do that. Okay.
Therefore, we have the worksheet.
The what?
The worksheet. That's
Yeah.
what it gives the work.
Okay, so that's quickly the thermal energy part that we needed to go over. Now let's go ahead and go over the conservation of energy. Conservation of energy is truly fairly simple. It's fairly simple. Okay, what it means is that energy cannot be. Okay, energy is conserved. Okay, so if I have an energy like this, if I have a potential energy here, and when I drop the pen, okay, what's going to happen to the potential energy?
It's going to decrease.
It'll decrease, right? Because I have a lower height. I have a lower height. Where did the energy go?
To kinetic energy.
It went to kinetic energy, so it had to travel, right? Okay, so you transferred potential energy to kinetic energy, right? But truly, potential energy plus the kinetic energy is always going to be the same. Okay, it's going to be conserved. Okay, so if I go from here, so this comes into play many different ways, right? So let's see if we can journey back for some of you and try to remember our, what did we talk about? We talked about free fall. We also talked about shooting up an object and it comes down, goes up and comes back down. We've done this before, right? Remember that? In math class, we talked about this. If you had an initial velocity of V naught, okay, if you had an initial velocity of V naught, the height at any given time, the equation was negative Does this ring a bell?
Physics.
Right, remember that? We talked about this. So this is going to be actually negative. If you're doing 32, if you're doing it in feet, right, it would be this guy plus V naught T plus S naught, where V naught was what the initial velocity that it went up with, right? And travels up and travels back down. Okay, so we've done this before.
What's S naught?
S naught is the initial position, initial height. So at this point, it would be 0 because you're shooting it from the ground, right?
Mhm.
So it's going to be 0, and this is all you're going to have left. H is going to be equal to negative 16t squared plus V naught t. Okay, so if you were in my calculus class, We talked about the velocity being the derivative of this. Right? Okay, we talked about this. Okay, so what's interesting here is this. What's interesting here is that there's no mention. Well, okay. Let's say that the object that we threw up, had a mass of m. Okay. What is my kinetic energy at this point?
Alex maximum.
It says minimum, isn't it?
Kinetic.
Yeah, because isn't potential at its maximum?
This is ground zero here.
Yes.
Yeah.
So there's no potential energy, right? Because the height is equal to 0 at this point. Because mgh, right? Remember? Remember potential energy was mgh. Kinetic energy was 1/2 mv squared, right?
If it's 0, then I don't know.
So v naught, so my kinetic energy at this point is going to be 1/2 mv naught squared, right? Okay, all right, that's my kinetic energy. Potential is going to be 0. So at this point, kinetic energy is at its max. Potential energy is at its minimum because it's 0. And it's going to go up at the very height. What is my velocity?
At 0.
0, right? So at 0, which means that my kinetic energy is 0, or the minimum, right? Kinetic energy, maximum, going away. So what's happening as we're going up? My potential energy as it going is going up, right? Right? Because I'm gaining height. So in other words, what's actually happening is that all my kinetic energy here is slowly being converted to a potential energy, right? All the way up to here. So at up here, my potential energy is what? All of it. What it's going to go? Let's say that okay. So let's call this the max height. We'll call it just h. Well, let's try to figure out what that is. Okay. So how do we figure out what the height was? Does anybody remember this? Remember doing this? So since the velocity is going to be equal to 0, you set this equal to 0, right? At the top, this is going to be 0. So this is going to be equal to 32t. Right? That's my initial velocity. So I can put that now into here. No. I know. Never mind. I know what this guy is. So my t now, I can go ahead and solve for t. And then I can put that guy into here. I can figure out what the height is. That's how you've done this, right?
Sure.
Okay, this is the way I mean, you were taught in honors pre-calc or AP calc. I mean, for AP calc for that matter, right? Okay. Okay. This is how you would solve it. It's kind of hard. So this now gives you a third way to solve this. And that is, since all of my initial kinetic energy is now transferred into a potential energy, I can solve for height. M's cancel out. I move the g over here, so I can get v naught squared over 2g is equal to h. Simple as that. I'm done. This is the max height. I don't have to do this and then put it back in this, find out what the V naught was, and then figure all this out. Okay. So my kinetic energy became potential energy. Okay. So this. Interesting part here is that there's no dependence or no relation to the mass. So whether I shoot up a itty bitty bullet or a cannonball, it'll still travel the same height, right? You would think that the bullet would go higher because it weighs less, right? But actually, that's the weight or the mass has no influence on the height. It's regardless of what, no matter what it is. It's the same thing as when you were dropping something from, when Galileo was doing his experiments, he was dropping from the top of the Leaning Tower, right? When you drop a little rock or a boulder, they both hit the bottom at the same time. Same thing. Get the same thing, right? Time to go up to here is the same as the time to get down to here, right? You knew that. We talked about that before. Okay. So that's basically, in a nutshell, what your conservation energy is. Let's go to page 439. Go to page 439. The way they write this is that the delta kinetic energy plus the delta potential energy and delta elastic energy. You see, traditionally, the equation does not include the elastic energy. So there are very, very few things that have to deal with elastic energy, right? You can just take that into consideration if it applies. So it's usually this delta K plus delta P is equal to 0. Okay? And if you look at the bottom of page 439, it gives you example 13.4. In the manufacturing process, carts are rolling down an inclined surface as shown in blah, blah, blah. Estimate the height from which the cart must be released so that as it reaches point A, the cart has a velocity of 2.5 milliseconds. Neglecting rolling friction. Okay, so all of the potential energy has to change to become, they have to become the kinetic energy, right? And the kinetic energy at that point, it was given as, since I know that the velocity is 2.5, right? My kinetic energy at the end is going to be 2.5 squared. And the height at which I release it from, and that's what we're trying to figure out, right? The potential energy used to be mgh, and I'm trying to figure out what h is. I know what g is. G is 9.8. I'm just trying to figure that out. So m's cancel out. I'm trying to figure out the height. So height is going to be equal to 1/2 2.5 squared divided by 9.8. Simple as that. And if you do that, it's 0.318 meters. Okay, and we're done. We're done for the day. So we are going to do, first of all,